Hey everyone, I'm Anupam. I'm on the Edge Web platform team at Microsoft. So today I'm going to present a new feature that we are adding in the async Clipboard API to get more parity with the native apps and also improve the copy-paste experience on the web. So before we talk about the feature, let me quickly go through the problems that we are trying to solve here. So in this example, I open native Win32 Excel app, type some text in a cell, and I copied it. And when I open the clipboard viewer, you can see Excel copied more than 20 different formats on the clipboard. And generating the data for each of the formats is expensive. And in Chromium, currently we have support for 3 built-in formats, HTML, plain text, images, but we have added, recently we have added a support for web custom format that enables the authors to write more than one custom format to the clipboard. So this is not just a problem with Excel. I think it extends to all the native apps that are trying to write more than 5 or 10 different formats to the clipboard. And producing data for that format is expensive because bitmap could involve encoding, decoding images, HTML format could involve sanitization, etc. So it takes a lot of time to write to the clipboard. So in order to make the copy-paste experience better, we introduced delay clipboard rendering, which gives the ability to the apps to delay the generation of a copied format until it is actually requested by a target app during paste. So just to give you an idea what it looks like, in the before picture, you can see Chromium copied all the formats to the clipboard, to the system clipboard. And when the user pasted in a native app, the native app requests one specific format that it prefers. And then the call goes to the clipboard, and clipboard returns the data for the format. And everything happens synchronously. But when we introduce delayed clipboard rendering into the mix, so you can see in the Chromium, we copy with delay render formats into the clipboard, and when the user pastes it in the native app, clipboard only requests the data. If the format is delay rendered, clipboard only requests the data for that format from Chromium. And then Chromium generates the data, writes it to the system clipboard, and the data then returns back to the native app. So our proposal here is mainly 2 parts. The first part is a web API change in the existing async clipboard API. And the second part is the infrastructure that interacts with the OS delayed clipboard rendering APIs, and also the clipboard message flow between the browser process and render process. So I'll talk about that in more detail later. So the first proposal, we are introducing a new callback that returns a blob in the clipboard item constructor. So the web authors have an option to either provide the data upfront, or they can just provide a callback to a format, and then create the clipboard item and write it using the Navigator clipboard write API. So when the web application custom format is requested by a native app, the generate expensive blob, in this case, the generate expensive blob callback is triggered, and the web authors produce the blob data for the web custom format, and that data is then returned to the clipboard. So now the second part of the proposal is basically a little bit more involved with how we interact with the OS clipboard. But before we talk about the OS APIs, just want to quickly describe the message delayed clipboard rendering message flow between different apps. So in the render process, we copy the formats with delay render, and then the browser process that has access to these OS clipboard APIs writes the format to the system clipboard. And when the user pastes it in the native app, so in the third step, when the paste happens in the native app, the system clipboard calls back into the browser process to read the data for the requested format. And then the browser process sends that message to the render process, and render process triggers the callback associated with the delayed render format and returns the data to the browser process, which then gets returned to the clipboard. And then clipboard returns that data back to the native app. After that, the paste executes successfully. So let me zoom into the clipboard components here. There are a couple of options to implement delayed clipboard rendering. So the first option is mainly supported by all the platforms, except Windows. However, there are a couple of ways to support implement delayed clipboard rendering. One is the Win32, which is a synchronous API, and the other one is an asynchronous API, which I'll talk in the next slide. So in the first option, when the async clipboard API copies with the callback, the system clipboard makes an IPC Mojo call to the browser process Mojo endpoint clipboard host symbol, which then synchronously writes using the OS clipboard API in the browser process to the clipboard. So when the user pastes it in the native app, the system clipboard calls back into the browser process with the delayed clipboard rendering message, and that call has to be blocked in the browser process. Because if we return, like from the browser process, the call returns without writing the data for the format, the system clipboard will return an error to the target app, and the paste will fail. So the call is blocked in the browser process OS clipboard API, and then we have to make a synchronous call to the clipboard host symbol, which then makes another synchronous call to the system clipboard in the render process. So here, as you can see, it has to be the red arrows indicate synchronous call. So you can see there is a synchronous call from browser process to render process. I can see some eyes rolling. So yes, we do make a synchronous call here because we cannot return the call from the browser process without populating the data into the clipboard. So when that call is in the render process, the system clipboard triggers the callback. Web authors populate the data in the callback, and the data is then returned back to the browser process where it gets returned to the clipboard. So this is the existing OS clipboard APIs on Mac, Android, and Windows. This is how the delayed clipboard rendering can be implemented if we want to support delayed clipboard rendering in Chromium. So we propose another option, which is an asynchronous way to read and write formats. But this is currently only available on Windows 10 and above, and it uses the new WinRT APIs. So the WinRT APIs is really a wrapper on top of the OLE-GET clipboard and set clipboard, which makes a COM RPC call from one app to another to transfer the data. So the only thing that changes here is so the red arrow turned to green. We make an asynchronous call from clipboard to browser process, and then from browser process to render process. So when the data in step 4, when the data is requested by the system clipboard in the browser process OS clipboard API, we create a deferral object and return it back to the system clipboard. The deferral object, you can think of this as like a promise-based object, which gets resolved later, the data. And once we return the deferral object, the call returns, we don't have to block the browser process. We post an async task to the clipboard host simple to fetch the data from the render process. And this clipboard host simple makes an IPC call to the system clipboard, which then triggers the callback, and the data is returned back to the browser process. And then in the browser process OS clipboard API, the deferral object is populated with the data asynchronously. So even that can be done in the background thread. So once the data is available in the deferral object, the system clipboard fetches that data from the deferral object. And if the native app is using the OLE-GET clipboard or set clipboard APIs or the WinRT APIs, they can use the deferral object. But if they're using the legacy Win32 APIs to read and write data from the clipboard, the system clipboard takes care of marshalling the data from the deferral object to the global shared kernel memory, and then the data is returned back to the native app from that memory. So this we prefer this the second option because it naturally fits into the Chromium multiprocess model, and there's no blocking call from the browser process to render process. But this is currently only available on Windows 10 and above. But we are planning to we will be implementing in other platforms once they have support for this API. But yeah, we have been in touch with Mac devs, the Mac OS devs, and they realize that it is a problem on their platform, and yes, there is a need for asynchronous read and write. We can block it. We can like block the clipboard call, because if you make synchronous calls, the native app, the clipboard, and the target app, the system clipboard, and the source app, all three are like blocked on one message, the delayed clipboard rendering message. So when the browser process is blocked, all the like you can't interact with other tabs or do anything. But with delayed clipboard rendering, we found there were some concerns when we were discussing this API with the editing working group. We found some, and our Google partners, we found some concerns with how the delayed clipboard rendering be handled on the web, especially in Chromium. So when a format is delay rendered, the web authors don't produce the data synchronously. And if the user chooses to close the browser or change the content of the active document, or like the browser crashes for some reason, which can happen, or the user just closes the browser manually, then if the user doesn't paste it in the native in an app, and the system clipboard doesn't have the data for the delay rendered format, then in this case, in this scenario, the paste would just fail, because like there's no source app to populate the data for the delay rendered format. So there will be a data loss on paste. And so we have discussed several options for this. Even on Windows, native apps like Excel, Office apps, and other apps, Adobe Photoshop, they handle it in different ways. There's no like a pattern, like a set pattern on Windows to handle this data loss issue. And so the simplest solution we came up with is to have one built-in format that needs to be populated up front. So if the web authors are writing just like one built-in format, they're not allowed to delay render it. And they have to produce at least one data for at least one built-in format in the clipboard write. And then if the browser closes, we have at least some data on the clipboard, and the user can paste it in other native apps. So we mitigate the data loss. But yes, there could be loss in formats, because like the expensive formats, usually web authors would choose the formats that are expensive to be delay rendered, and those formats would have all the formatting details, images, and stuff. So there is a partial data loss and a format loss. So there really is not a very good way to handle all the cases, but at least there will be no data loss, and we'll have other mitigations in place to the web authors could register a before unload event handler, and we could pop when we see a event handler in the before unload event, we could trigger all the callbacks and give them a chance to populate it within a timeout window and things like that. So it's still in flux, but this is one solution that we want to pursue, and then experiment with the web authors and see which one they prefer. So if you want more details, I have linked the Google Docs, which also has enumerated all the options for the tab browser close issue. But there is a privacy concern with the delayed clipboard rendering format. So just to quickly describe what it is, if there is a random site foo.com that somehow is aware of the web custom format produced by Excel Online, and writes the web Excel custom format to the clipboard with a callback, the system clipboard tags it as a delay rendered format, and then when the user pastes it in native Excel app, the system clipboard calls back into the source app, so in the browser, to read the data for the web Excel custom format, and then we trigger the callback associated with that custom format. So in this case, even though foo.com is not a legit site, it may be a legit site too, but they may not know how to parse the Excel web custom format. They could just use it to track the user behavior, and we don't really have a good mitigation for this privacy concern, because we aren't really sure if it's actually a privacy concern, given that it's so scoped, and the user, like copying from the foo.com site, has to paste it in the native Excel app. And there's some app that reads the Excel web custom format, and that's the only way to trigger the callback. But there is a possible mitigation to support delayed rendering of only the built-in formats and just like discard web custom format. But that makes the API less useful because there are only, currently we only support 3 built-in formats, even though we are planning to add more built-in, the native formats in the future. But web custom formats gives more flexibility because it's not tied to a specific like parsing algorithm or a specific data type. So yeah, if we only support delayed rendering of built-in formats, it will make the API less useful. So we could always experiment with other options, but I would love to hear thoughts on how we can mitigate this privacy concern without, making it more restrictive, making the API more restrictive. So here I provided my email address if you want to talk about all the about privacy or any other issues in more detail. We have also filed feedback. We have also filed GitHub issues for feedback in the editing working group repo, and so you can check that out. And if you want to comment on the web API shape or the the tab browser close issues and other like issues with the delayed clipboard rendering proposal, you can engage with us there. And I also want to thank our partners at Google and Microsoft Office for giving us constant feedback on this proposal and helping us with the design. So thank you. Take questions if you have any.
All right, we have a question from the audience.
Yeah, thank you for the great presentation. I have a question, maybe a bit open question about the last issue with the data loss when we rendered some formats and then kind of closed the application, the source application, or closed the context in which the copy was done. So the question is, shouldn't this problem be resolved at the platform level, not by the application? Because it looks common for all the system, right? That initially we only send the formats, and then something happens, and we cannot render the data which we promised. So probably it should be done at the level of the API, so that we would maybe get some scoped context which would be fulfilled when we exit the context in which the copy was done. So this is not something which can be resolved from the application side. It should be done together with the platform, and maybe the protocol should be changed, the API for the clipboard. But yeah, the question like this.
So when you say the API, is it the OS APIs that you are referring to? Is it this like the OS system clipboard? Because it does return, it will return an error. On Windows, it returns an error H result in paste, but on other platforms, it will error out. So it will return an error code that the app can handle gracefully, and they can gracefully exit and say, hey, paste operation failed or something. That's what native Excel app does currently on Windows. But the app can also choose to show an error dialog or something to the user.
So okay, so I understood it like the application can decide when to supply the data, right?
Yes.
So it can be done from the application side. But my idea was that probably there should be also some protocol to request the data. For example, if we close the application, the operating system apparently knows that we are closing, and it may request the data before we close, like this.
Yes.
I don't know.
Yeah, that's a good point. So in Win32, we actually get, if there is if the system clipboard sees a delayed render format and the process that put the delayed clipboard rendered format on the clipboard is shutting down, it sends a delayed rendered Windows message that, hey, you should, there are some delayed rendered formats on the clipboard, and you should this is the last opportunity for you to populate the data for those formats. but we don't want to slow down the shutdown process, so we don't handle that message, and we just like terminate it. So the format doesn't have empty data. The delay rendered formats just have empty data on the clipboard. But we could, so this is one of the options that I described in the Google Docs, that we could have some sort of a timeout mechanism during the shutdown process to give the web authors a chance to populate the data. If not for all the formats, maybe they can populate one format that is currently, that's variable to them, maybe in Excel. In case it would be web Excel format, in Photoshop case, it'll just be an image or something. So yes, we have thought about those mitigations in the application side. And OS Clipboard's APIs, I think on Windows. I've only tested on Windows, but I'm sure there's some way to do it on Mac OS too. I don't know about Android and Chrome OS, but we can always talk to the OS devs to figure out a good solution. But yes, yes, we have some mitigations in place to not delay the shutdown process too long, but delay it enough to at least have the give the opportunity to web authors to generate the data for the delay rendered format. Thank you.
All right, looks like that's all our questions. Thank you very much.
Thank you.